Hello students, in this video we will discuss about the dimensional consistency, that is to check the dimensional correctness. This is the second application of dimensional analysis. Before discussing this, we will discuss principle of homogeneity of dimension. What is the homogeneity? Homogeneity means you can say the same. For example, if this is S is equals to ut plus half at square. You all know that this is the equation of motion. S equals to ut plus half at square, where S is the displacement, u is the initial velocity, t is the time, a is the acceleration, that is constant acceleration. This is homogeneous. Why? Because this part, and this part, all the terms have same dimension. In other words, we can say that if every part or each side of the equal symbol, if the dimension is same, that means we can say that is the homogeneous equation. Means every part of the, or we can say that every term of the equation must have that same dimension. If they have same dimension, then the equation is homogeneous. Okay, uh, this is to check the dimensional correctness. Let us check the dimensional correctness of this equation. This is S equals to ut plus half a t square. This is first example. Okay, this part, this part, this part means same type of quantity be equal. Simply we can say that if two quantities are same, then they may be equal. Same, in other words, we can say that two terms are added, means two terms only will be added if they have same dimension or they have the same type of quantity. Means velocity will be added with the velocity, displacement will be added with the displacement, okay, acceleration will be added with the acceleration, force will be added with the force, or subtracted, may be added or subtracted. Two different type of quantity, means velocity and time, may be multiplied. Two different type of quantity we can multiply, but only same type of quantity we will add or subtract, or same type of quantity will be both sides of the equal to. Hope you are getting. Let us check the dimension whether the equation is homogeneous or not. This is the S, means displacement, and we know that the dimension of displacement or length is L. This ut, dimension of u, that is LT minus 1, and dimension of t, time, is t. Combine these two equations, what you will have, t to the power minus 1 plus 1, that means t to the power 0, that is 1, simply L. Half at, dimension of half at, sorry, at square, ut plus half at square, this is half at square. This is 1 by 2, does not have any dimension. A is the acceleration, that is LT minus 2, and t square is t to the power 2. After solving, you will have L t to the power 0, or simply L. See this dimension, S dimension, this is L, ut have dimension L, and half at square have dimension L, means every term of that equation have the same dimension. That means this equation is dimensionally correct. This equation is dimensionally correct, or we can say that this equation is dimensionally consistent, but it may be incorrect. Any equation may be dimensionally correct, but it may not be mathematically incorrect or theoretically incorrect. If, let us suppose, if this is 1 by 380 square, this equation is wrong, but this equation, dimensionally this equation is correct. Why and how? S, dimension of S is L, dimension of UT is L, dimension of 1 by 3 LT. 1 by 3, if you have 1 by 3 dimension, 1 by 3 have no dimension, that means A will have LT to the power minus 2 and T square will have T square. On combining you will have only L. Only L means this equation have L, L, L. Every part of the equation have L, L, L dimension. That means this equation is dimensionally correct, but mathematically or theoretically it is incorrect, because this should be 1 by 2. Okay. Next example, that is check whether the equation dimensionally correct or incorrect. mgh is equals to half mv square. We know that this is potential energy and this is half mv square. This is kinetic energy. This is energy and this is energy. This is same type of quantity. It may be equal. Let us check whether this is dimensionally correct or not. This is mgh. You know that m is the mass, that is m. G is the acceleration, means meter per second square, that is LT minus 2, and h is the height, that is length, that you will write L, and after combining you will have ml square t to the power minus 2. Just put 1 by 2 mv square. M is the mass, dimension is capital M. V square will have what? Meter per second whole square. Simply we can write meter square per second square. Meter square means L square. Second square means t to the power minus 2. And after combining you will have ml square t to the power minus 2. This shows that the every side, means both the side of the equation have the same dimension. This is ml square t to the power minus 2. That means this equation is dimensionally correct, or we can say that this equation is dimensionally consistent. Hope you are getting, and thanks for watching this video.